We are familiar with changes of state in our everyday life because water readily undergoes several of these changes of state. For example, water will freeze to ice and then melt back to water. It will also evaporate or boil to the water vapor, and then it will condense from water vapor to liquid water. So as a substance is heated, the particles begin to move faster, and the attractive forces that hold molecules together in the solid and liquid state become less important. As we go from phase to phase or state to state, those are known as state changes, and they have special names. We are well aware that freezing is going from liquid to solid. Melting goes from solid to liquid. Evaporation or boiling goes from liquid to gas, and condensation goes from gas to liquid. Sublimation and deposition we're not as familiar with. It doesn't happen as often to water. It does happen, sublimation happens when dry ice is put at room temperature. It goes directly from a solid to a gas. It does not melt. It just goes directly from a solid to a gas. And we observe deposition when something goes from the gas phase directly to the solid. It doesn't go to a liquid first. It goes from gas to solid when we see frost on a window pane. So this graphic on the slide in a triangular form indicates the different phase changes between the three states. And the arrows are colored red for the phase change that requires energy. As we go from a liquid to a gas, we need to give heat to those particles so they can move faster. As we go from a solid to a gas or sublimation, we need to add heat to those particles so they can move more and go to the gas phase. As we go from a solid to a liquid, we need to add heat to that solid so those particles can move past one another and get to the liquid phase. The opposite processes occur when something is cooled, when a phase is cooled down or heat is lost. So to go from the gas to a liquid phase, that gas needs to be cooled down. To go from a liquid to a solid, that liquid needs to be cooled down. And to go from a gas to a solid, that gas needs to be cooled down. So phase changes always have a flow of energy. Either energy is added to get to a higher energy phase, or energy is lost, heat is lost to go to a lower energy phase. And when I'm talking about the energy of the phases, I'm talking about the kinetic energy of the particles. So in a gas, the kinetic energy of the particles is very high. These particles are moving very quickly. In the liquid, they are not moving as quickly as in the gas, but more quickly than a solid. And in a solid, the particles are vibrating, but they're not moving past one another. So gas has the highest kinetic energy particles, liquid has the less kinetic energy, and solid has the least amount of kinetic energy in its particles.